Bismillahirrahmanirrahim. In the name of Allah, the most beneficent and the most merciful. Guys, as I already told you that I'm solving the past paper AP Calculus 2018 and we already solved from question 1 to question 21. Now we are going to solve question number 22. This question has a deep knowledge of series, right? It has, you can say, the deep knowledge. Okay, so I will tell you each and everything. Maybe this video will be long, but you will get benefit, inshallah. And I will give you a lot of knowledge about series. Okay, because this question is based on series. There are many special type of series. Integration test are hidden here. Okay, so I will tell you each and everything in detail. Well, we start now. Which of the following statement about the convergence of the series is true? Okay, so a series is given from n is equal to 1 to positive infinity. Means we are going to start from 1 to positive infinity. Means you can just start from 1 2 3 4 5 6, right? So if you just put it here, it becomes 1 plus 1 2 ln 2 1 divided by ln 2, right? Then this means summation, so just add all the terms, like 1 divided by ln 2 plus 1 divided by ln 3 plus 1 divided by ln 4 and so on, right? So this will give you the convergence, divergence, what is going on. These four statements are given and you have to tell. Okay, so I'm going to tell you about the first, this series, what does it mean. And this series has convergent or divergent by the comparison with this series 1 by n or 1 by n square, right? So here, first of all, I'm going to tell you here, there is a concept here which is called P series test, right? P series test. You can say this is answer. P series. What is a P series test? A P series test is a special type of series with infinity, right? If you have any series of infinity, right, then we can find out the P series. This is very important concept, very important in calculus, right? P series test. Again, I said to you, this is the series of infinity, right? So for example, I'm going to give you one series, okay? And the series is like this one. Listen, for example, n is equal to 1 to positive infinity 1 divided by n power p. Okay, this is you can say I have given 1 divided by n power p. This is very important. Okay, so please have a look. 1 divided by n power p, right? So here I'm going to find out two conditions. Okay, note, if the value of p, if the value of the p is, if p is greater than 1, if the value of the p is greater than 1, like 1 divided by n square, 1 divided by n cube, 1 divided by n power 4, 1 divided by n power 5, okay, with n is equal to what? Here it is written what? N is equal to 1. You have to write here 1 and 1 power what? For example, you can say I will start from 1, for example, right? So here you can say this is this one, this p here, right? The function is like this one, 1 divided by n. Okay, the series, the limit, n is equal to 1 to positive infinity is my summation, right? Everything is we'll see, but if the value of the p here, if you see this is greater than 1, then this series always, you can say, then this series n is equal to 1 to positive infinity 1 divided by n power p is always convergent. Convergent means it has a specific answer, right? I mean, this when you solve these questions, you have a specific answer, right? So we can say that this series has convergent, right? if the value of the p is greater than 1. For example, 1 divided, this summation with 1 divided by n square, 1 divided by n cube. Example, I can just say you, example, you can say 1 divided by n square, 1 divided by this one, n is equal to 1. You have to start from 1, right? 1 to positive infinity. In the same way, n cube, 1 divided by n4. If you have a series like this, then we will say that this will always give you a convergent values, right? It will be always convergent, okay? Now, if okay, now if the value of the p is less than equal to 1 or less than equal to 1, if you see this one, right, then we will say this series, then this one n is equal to 1 to positive infinity, 1 divided by n power p is always divergent. Divergent. Divergent means the answer will be always infinity, right? When you solve these questions, and you will get, this is what divergent. Divergent means infinity, right? So whenever you have an answer, the p is 1 or less than 1, like n power 0.01, 1 divided by n, and the value of the p is 0.001 or 0.2 or 0.3, right? So example, you can say 1 by n, 1 divided by n 0.1, 1 divided by 0.5, something like this one, okay? And here is the summation, means start from 1 to positive infinity, then this always give you the divergent. This is a very important here, right? Means the answer will be divergent, means there is no specific answer, anything you can just take it, so the answer is infinity, you can say, right? Okay. So this is called the p series test. So here in this question, okay, the p series test is hidden, right? And I give you the idea of this one. One more thing I want to tell you, in p series we have 3 types of series, right? AP, GP and HP, means arithmetic progressions, geometric progression and harmonic progression, right? You can say harmonic is just the reciprocal of arithmetic progression, right? So I want to tell you, if the value of the p is 1, for example, right? If the value of the p is 1, it becomes, this series become HP, harmonic progression, harmonic series, right? So here, this is the case I'm going to tell you here. So like for example, 1 by n, okay? So if you have a test, this one, okay? So for example, if you have, you can say I have a series, right? N is equal to 1 to positive infinity, 1 divided by n power p, right? And if you can say p is equal to 1, so it becomes what? A series of n is equal to 1 to positive infinity, 1 by n. So this is called harmonic progression, right? Okay, harmonic series, then you can say 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 to infinity, right? So such type of series is called harmonic progressions. This is another case, but you can say HP is a special case of P series test, right? So HP is a special type of P series test, right? What is a P series? P series is a series of infinity series. Okay. Now here, if you can see, we have A, B, C, D, 4 answer, right? So here, this one, 1 divided by ln n plus 1, okay? This is convergent and this is divergent, okay? Okay, we will solve these questions later, means after this one, because I have no place, okay? I will tell you, but this series is going to compare by this series. So, okay, so we will just say this one, this is convergence by the comparison with this one. So as you can see, 1 divided by n is equal to 1 to positive infinity. What is the value of the p here? You can say 1, right? So this is harmonic series, or you can say, okay? So if this is a harmonic, means if the value of the p is 1, then we can say this is always divergent, right? So harmonic is also a divergent series, right? Series, okay? So as you can see here, it is 1. If this is 1 or less than 1, then this series is always divergent. Number 1, right? And if I talk about this one, is you can see here, because here p is 1, right? Here p is 1. Here you can say p is 2. So if this is greater than 1, right? As I told you here, if this is greater than, then this has a convergence, right? So you can say this is convergent. This converge, and this is divergent, right? So here you can say, so here again 1 by n, so it means this is divergent. 1 by n square, so this is what? Convergent. So I have already mentioned here, if you have any harmonic series, right, this always give you an infinity value, means it's, you can say, this is a what? A divergence, and this is what? A convergence, right? Okay, now I'm going to tell you about 1 divided by ln n plus 1. It's a convergent, it's a divergence. Here we are going to solve this question, right? So I want to tell you, if you find 1 divided by ln x, right here. Okay, first I will tell you here. Okay, it's a very important lesson, right? Okay, now if I say here we have a series, right? N is equal to 1 to positive infinity, 1 divided by ln n plus 1. This is what? It's a divergent or the convergent. This is very important here, right? So as you can see, this is what? If you put here 1, it becomes what? 1 divided by ln 2 plus 1 divided by ln 3 plus 1 divided by ln 4 and so on, right? So this one will give you a divergent value or the convergent value, okay? So now I am saying to you, because I'm a teacher, I'm teaching calculus last 18 years, so I know the nature of such series, right? So I can tell you, if you have 1 divided by ln, right, or 1 divided by log, right? And so this series is always divergent, okay? Series is always divergent, okay? If you say, just prove this one, sir. Professor, can you please prove that? How can we know that this goes to divergent, right? So I will prove right now. I will give you an integral test, right? And there I can make this series is a divergent, right? So as you can see here, I have written the options. So my board is full, okay? I am going to erase this one, and then I will prove that this series goes to divergent. And that is a very, very, very important concept. Maybe in another past paper, this question may be asked, okay? So 1 divided by ln 2 plus 1 divided by ln 3 plus 1 divided by ln 4, it's a divergent or convergent. So next, when I erase this one, I will prove that this is divergent or convergence. For a while, right now, I'm going to tell you that this series goes to divergent, okay? So now I'm going to ask you a question. So I'm going to tell you the answer here. So see here, this series 1 divided by ln n plus 1 convergence. No, I said to you, whenever you see this one from 1 to positive infinity, this series goes to divergent. So this is convergent, this is convergent. So these two questions are wrong, right? So we can say A is wrong, B is wrong, right? Okay. Next, if we see about C, okay, this is divergent, means this is divergent. Okay, so now we have to see that this is satisfied with the comparison of this series or this series. Okay, so this is divergent. Okay, and what about 1 by n? What is 1 by n? Can you tell me? 1 by n, as I told you, 1 by n is divergent, right? Again, here I have written 1 by n is divergent. I'm going to write down here 1 by n is what? Divergent. Okay, and 1 by n square is what? Convergent, right? Okay, so you can say this divergent with this divergent, right? Okay, this divergent with this, no, this is wrong. Okay, so this is also wrong. So my answer here of this question will be that if we compare the given series with this series, right, then we can say answer C is right. Okay, so because this is divergence by the comparison test with 1 by n. Okay, so I hope guys you all understand, and now I'm going to prove that this series is a divergent. How? I'm going to tell you everything in this video. Okay, your answer is now finished, but I'm going to prove right now. Okay, so first I'm going to erase this one. Okay. Okay. Well, I'm going to prove this one. This series 1 divided by ln n plus 1. Okay. So first of all, I'm going to tell you something about the integral test, right? Integral test. Listen. Integral test. Okay, this is very important, so please focus on that. Listen, for example, note if I have fx, if I will just convert this one into a simple language so everybody will understand that. If you have fx, okay, if fx is given, and this fx, what is the nature of this fx? This function will be positive. Number one, if this function is positive. Second, continuous. Positive, continuous, and decreasing on an interval which is here is 1 to positive infinity. You can say 1 to positive infinity, right? Look again, if you have a function which is positive, I'm going to tell you three nature of that function, right? Positive, number one, positive, continuous, and decreasing, these three things, right? On 1 to positive infinity. If you see this one, right? If you have these three things, right? Positive, continuous, and decreasing on this interval, then we can say for fx is equal to an. You can say this fn, not fx, fn. We can say for n means you have, if this value is 1, for example, right? So if I can just find out from fn to an, right? So there is a condition here. Then we can say if fx is positive, continuous and decreasing on this one, then we can just take any value of x, which is called n, right? And we can make this series, we can make infinity series, right? Means fn is equal to n. We can say fn is equal to, what is fn, what is n? How can you find an? Very simple. You have fx, then in place of x just put it what, fn, right? So that fn is always equal to n. Doesn't matter, right? So n is also a specific number of a particular domain on the interval, right? Okay. Then what is that? Please listen carefully. This is very important, right? If the series is, if we have two cases, if integration of a to infinity fx dx, again, if a to positive infinity fx dx, if this one is convergent, for example, if you prove, if this one is convergent, then we can say n is equal to 1, which is an to positive infinity an, this an, and this an we will get it if n, if these three conditions are developed, right? Then we can say for any value of n, from n1 to positive infinity, a power n converge. First rule, right? If a to positive infinity fx dx, if you prove that this is convergent, then this series will be convergent. Second, if a to positive infinity fx dx divergent, then we can say the same thing, n is equal to 1 to positive infinity an divergent, right? So now I have this one, I have a function, okay, and then we are going to make a test three things. We will see positive, continuous and decreasing. If we know the graphs, as I told you, I'm a teacher and I have a lot of practices on the graph, right? So if we can prove that I have a function which is positive, continuous and decreasing on this interval, and then we will solve that, we will find out the improper integration. What is the meaning of improper integrations? When the lower limit is a specific number but the upper limit is infinity, right? So we will solve that function, and if this is convergent, then we can say this is convergent. If this is divergent, then we can say the series is divergent. But again, I told you in the question that this, whenever you have 1 over ln, it's always give you divergent, right? So I will prove now, because in the questions I didn't prove, I just say by myself that this series goes toward divergent. But now I'm going to prove this one, okay? So these are two conditions, so I have to prove this condition, that the series, means this one, a function, is divergent, okay? So this will be divergent, okay? So let's see the proof now. These three things, positive, continuous and decreasing, right? Okay. Okay, now answer. For example, I have a function, for example, I have a function fx which is 1 divided by log x plus 1. 1 divided by ln, not all log, that's ln. Because here is ln, right? If you have ln x plus 1, okay? Now I'm going to find out the nature of this one, okay? So if you have 1 divided by ln x plus 1, so the graph you will see right? Okay, so this will be what? 0, 1, 2, 3, 4, minus 1, minus 2, minus 3. Okay, I'm going to make a rough graph. Okay, so this is your minus 1, right? It's not like that, you can say. Okay, so the graph will be in this direction, and here, and so on. It's this direction, right? This is the graph of 1 divided by ln x plus 1. Okay, this is the graph of this one. You have a lot of graphic calculator, Desmos and mathway.com. You can check this one, right? 1 divided by ln x plus 1. This is the graph of 1 divided by ln x plus, because inverse function, right? And in both cases, now I'm going to find out these three things, as I told you. What are that? First of all, continuous. Okay, we have to check what? Continuous. Continuous, first point. Second, positive. And third one, I said to you, decreasing. I'm going to tell you all the details of the calculus, all the details, okay? So don't understand that this question is going to be long. My main intention is to give you a lot of knowledge, okay? These three things: continuous, positive, and decreasing, right? Okay. So as you can say, our interval is given, which is, for example, I'm going to take an interval here from 1 to positive infinity. Forget about all these things, okay? So I have this one. So as you can say, I'm going to consider only from this part, from here to here. From here to here, okay? So you can see this is continuous. Number one, this is satisfied. Number two, positive. With the graph, you can say if you have any value of x which is greater than what? Equal to 1, it's the positive value, right? The function is always, function fx is always positive, right? Now the point is decreasing, right? You have two options here. Number one, the graph is going down, right? So from the graph, it is clear that this is decreasing. This is what? Decreasing, right? So you can say from the graph, you can say function is what? It's positive. Function fx is decreasing. Decreasing. D-E-C-R-E-A-S. Fx is decreasing. Function is decreasing, right? As x greater than 1, right? These three conditions are satisfied. And one more thing here you can just prove, okay? We have alternate way that if you prove that f of prime x is less than 0, means the derivative is 0, then the function is decreasing. I'm going to prove here right now, okay? So that you can just see here. So note, okay? One way is to see the function is decreasing from the graph. Second way, if you know the derivative, and that derivative for some specific interval, the derivative is negative, then we can say the function is negative, right? So I have this one, fx divided by 1 by ln x plus 1, okay? I'm going to find out f of derivative, right? So we will check it. Let's see. So f of prime x is equal to d by dx 1 divided by ln x plus 1, right? Okay. So you can just use division rule, okay? So ln x plus 1 d by dx 1 minus 1 d by dx ln x plus 1 divided by ln x plus 1 whole square, right? So d by dx 1 is 0, so whole 0 here. So this is 0 minus 1, 1 is 1, and d by dx ln x, right? So this one is, you can say, it will be 1 divided by x plus 1, and this is also 1 with using the chain rule, you know that. So it is ln x plus 1. It's always give you positive, so you can say minus 1 divided by x plus 1 x plus 1 whole square ln x. as you can see guys, this one is always positive, okay. So if you have minus 1 divided by x plus 1, you have this question, right? So if your value is n is equal to, for example, if x is equal to what, greater than 1, okay, you can say here 1, x is 1 or greater than 1, right? So you can see if you put 2, 3, 4, 5, 6, if this is positive, so this is positive, and positive, negative, negative, so always give you negative value, okay, for x is greater than 1, right? For each and every value of x which is greater than 1, the derivative is always negative. And I prove this one now with the graph, with the derivative, that this function is decreasing from this interval, right? It's clear now. So we just proved that these three things, the function is continuous, positive, and decreasing. Then we can say we can develop a series, right? Then we can say then we can write what we can write. Okay, then we can write here that there is a development here. Okay, can say Fn is equal to An. We can generate now. Okay, so Fn, how will you find Fn? Your function was fx, right? What was the fx? Fx is what, 1 divided by ln x plus 1. So I need Fn, it becomes Fn, so it becomes what, ln n plus 1. And now this Fn is equal to what, An, so we can say this An is equal to what, 1 divided by ln n plus 1, right? Now this is convergent or divergent, it depends upon the integration test, right? Now we can say, so we will just find out this one. This is means fx lower limit is what, a, for example a, okay, here is 1, okay, and this is what, positive infinity, and then I'm going to check fx, right? If this is dx, if this one is what, if this is divergent, I will prove that this is divergent. If this is divergent, then we can say this series is what, divergent, okay? So now we are going to solve this question first. This question is long, but it will give you a lot of information. Okay. See, so I'm going to solve here, okay? Okay, so this is what, integration, right? And this is 1, this is what, positive infinity, right? Fx is 1 divided by, I'm going to check it, fx, which is ln x plus 1, right? And this is what, dx, okay? I'm going to solve this question, okay? And then we will see it, and I will prove that this is divergent, okay? Let's see. So as you know, this is improper integral, right? Improper integral. So first of all, I'm going to solve these questions, then we will see it. Okay, so this is your fx, right? Okay, so how will you solve this question? So let x plus 1 is equal to t, for example, right? So this is, can say dx is equal to what, dt. So if you come here, okay, this will be what, 1 to positive infinity, 1 divided by, this is what, ln t, right? So 1 divided by ln t, and this is what, dt, right? So right, so if you say 1 divided by ln t dt, and this 1 to positive infinity, right? So okay, so what will I do again, right? And I will say, what I will say here, ln t is equal to z, for example, right? Then ln t is what, 1 over 3 dt is equal to dz, right? So dt is equal to what, t dz. We want t in the terms of z, right? So can you please here just focus here, because here is dz is okay, dz we have t here, t we have to write in the terms of dz, right? So what we have to do, you have ln t, right? ln t is equal to z, right? We are going to make the base e on both sides, okay? Always remember, whenever you have ln, you have to take e, okay? So I'm going to make this e, okay? So this is ln t, and we can say here e is what, a z. And remember one thing in your mind, if there is a formula here, if you have e power ln fx, I told you this one in the previous video, right? So this is fx. If you have e power ln, this is cancel and you have the fx, okay? So you can say e power ln, so we can say t is equal to e power z. Wow. Right? So now we can say, find this point, okay? And here we have, this is what, 1 to positive infinity. And at the end, I will change each and everything in the terms of, the terms of t in terms of x, right? So 1 to positive infinity, 1 divided by, okay, 1 divided by, this is what, ln t, which is what, z, and what is t? This is what, t dt, okay, 1 by z, okay, dt is t, and t is what, e power z, and this is what, dz. So we can say we have 1 to positive infinity, right? So 1 over z, or e power z divided by z dz. Okay. Now I have a series of the series of e power x or e power z, right? So if you have e power x a series, this is always, I mean, you have to memorize this one, okay? E power x is 1 plus x square factorial 2 plus x power 3 factorial 3 plus x power 4 factorial 4, and so on. This is the series, you can say the approximation value, right? Okay, this is approximation value. E power x is equal to 1 plus x. This is near about this one, okay, and then this one. So here if you see, this is e power z, so here it will be 1 plus z squared by factorial 2 plus z cube plus factorial, right? So here we can just say here 1 to positive infinity, right? Okay, and here we can say e power z, which is what, 1 plus z square factorial 2 plus z 3 divided by factorial 3 plus z power 4 factorial 4, and so on, divided by what, z, right? And then dz, right? Okay, so what is the answer here? You can say 1 to positive infinity, it will be 1 by z by z is 1, then z cancel, z by factorial 2, then this is what, z square factorial 3, as you can see, right? Then you can say z power 3 factorial 4, and so on, right? This is what, okay. So again, I'm going to solve this question here. Just 1 minute, I have to get my so now we can just erase which part I have to erase, this part, okay, and this part, okay, from here to here, okay, I have no problem with that. Okay. Okay, so you can see here 1 to positive infinity 1 by z, right? 1 by z dz, right? And then plus, don't say it right now, just wait 1 minute. 1 by z plus 1 plus z divided by factorial 2 plus z square factorial 3 plus z3 factorial 4 and so on, right? This is what dz. When you integrate on both sides, okay, when you integrate on the both sides, you will find 1 to positive infinity 1 by z dz plus 1 to positive infinity 1 dz, okay, and plus 1 to positive infinity, for example, right? Okay, let's make this limit, okay, and if we integrate, okay, for example, just forget about this one, okay, you just integrate because this is upper limit. I know one formula, we can use the limit here, right? Okay, 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 so we can say this is what, if you integrate, this is 1 over z, 1 over z is what, ln z, right? And 1 is what, z, and then you can say this is what 1 over factorial 2, this is z square by factorial 2 divided by 2, then it will be what, 1 by factorial 3, and this is z by 3 by 3. In the same way we can say 1 by factorial 4, the power 4 by 4, which is factorial, right, and so on. And this is our limit. This is our limit. I'm going to write down here, which is what, this is infinity, and this is what, 1, right? Forget about everything. Then again you can just you can say this is what, ln z plus, look here I'm going to make a summation. You can say n is equal to 1 to z, z is equal to n terms. For example, here I'm going to write down z power n. So z power n, the 2, 3, 4, so where to infinity, right? For example, here you can say divided by, this is what, n factorial into n, right? And this is what, positive infinity to 1. Now you can see this one. This is very important. The integration of this part, this integration of this part is ln z, right? And this is, you can say, if you put 1, okay, so this is what, z. This is what, z2, so factorial 2, 2, right, 3, and so on, right? So you can say this is, and then you can say plus c. You can make a plus c, right? So you can say this is plus c, and then I use a positive infinity and 1. But here I'm not going to use because I know one formula for integrations. So this is the integration of 1 over ln z. You can say here, if you say ln z, and 1 minute, this is because I do not change, or can say here we didn't change, so this is what you can say ln z. What is z? Ln t. So you can say ln t plus this one is what? This is what, n is equal to 1 to infinity, and what is z here? The z is ln t. So this is ln t, and power is what? N divided by n factorial, this is n, right, plus c, and again right now, because I didn't solve, this is just a finite integrations, right? Okay, it's not a definite integral, okay, it's an indefinite integral. And then what is the value of t? Here I just put it x plus 1, so it didn't change, right? So we can say this is what ln. My god, this is not working, so we can say that this is what ln, right? Ln, and this is t. What is t? X plus 1. So x plus 1, right? ln z to ln t, and t is what? Z was what? No, wait. I'm going to write down here. This is ln, and z is equal to what? This one, ln t, right? So this is ln t, right? Plus this is n is equal to 1 to infinity, right? And this z is what? ln t. This is ln t, and here power n divided by n factorial n plus c, right? This is positive infinity, and here this is ln, and what is the value of t? X plus 1, so you can say that x plus 1, right? And plus to infinity to positive infinity, this is ln, and what is t? T is x plus 1, so this is what? X plus 1 power n divided by n factorial and plus c. Here this is positive infinity to 1, means we just I know the formula. Now I'm going to tell you. Okay, this is the integration of this one. I'm going to write down here. Okay, so here here you can see 1, okay, to positive infinity, right? Or you can say not 1, just write down a, and or you can say 1, no problem, I have no problem with that, or a to infinity, right? And if you have 1 divided by fx, 1 divided by fx ln x plus 1, so this is equal to 1 divided by ln x plus 1, which is equal to ln x plus 1, right, plus summation of n is equal to 1 to positive infinity ln x plus 1, and the whole power is n divided by n factorial n plus c, right? Okay, this is and here I am going to write down this value, which is what? Positive infinity to a, or you can say forget about this one. This is the integration of this one, right? Forget about this one. This is the integration of 1 divided by ln x plus 1 dx is equal to this one. I just proved this. Okay, now there is an integration, improper integration formula. I'm going to prove it here. Okay, here there's improper integral, improper integral with infinite integration. What is that? That this is a to positive infinity fx dx can be written as from a to b, where you can make a limit b tends to infinity fx dx, right? This one. So you can say our question was 1 to positive infinity 1 divided by ln x plus 1 dx. The same thing was here, so this is what limit, right? And b tends to what? Infinity. And here our limit 1 to positive infinity, right? We don't say this one, okay? Because and this fx, which is 1 divided by ln x plus 1, which is this series, and I'm going to consider only this part, okay? I'm not going to consider a lot of parts, okay? I'm going to just consider this part only. So we can say ln, right? Again we have a problem of the marker. Limit, you can say ln x plus 1, okay? And this is what? Infinity. And this is what? 1. Okay? This is integrations, we just find out with the integrations, okay? The answer, this one, I'm not going to take this whole integration. This is your fx, right? Whatever you form when you solve this question. And the upper limit and lower limit, I have just mentioned it here, right? So a and b, this is, I just write down, and when you solve fx dx here, this is fx, this is your fx, okay, and this is your dx. So when you solve this question, you have this one, and then I use it. Okay, now what will happen? Okay, this is, you can say, this is b, for example, and b tends to infinity, right? This is b, b tends to infinity. So what you have to do, in place of x, just write down b. So this is what? Limit b tends to infinity ln b plus 1, right? Minus ln, and this is 1 plus 1, okay? We use this definite integration here, I use this minus, and my dear, b tends to infinity, listen, b tends to infinity. So whenever you give b tends to any infinity, any largest value, it will always give you infinity, and this will give you a number which is c. Infinity minus c is always infinity. It means this series is divergent. It's the proof now. It's the proof now that now this, you can say, this one leads to infinity, means this is divergent. And now we can say, when this is divergent, then we can say, do you remember I told you here, I told you that if a to positive infinity fx dx, if this is divergent, then you can say an is also divergent. So what was an? The an was this one, n is equal to 1, positive infinity, 1 divided by ln n plus 1. Now you can say that this is divergent, and now it's proved, right? I hope guys you all understand. Again and again, it was not my intention that I will solve this question and it will take 1 hour. No, I already solved this question before, but now I want to give you the full idea that how you can say that this integrations goes to a divergent. I hope guys you all understand. Still you have a problem, you can just mention the comment. Whenever we have a time, we will discuss it with you. Assalamu alaikum. Bye bye.